what you have to understand is that every 3 years that code gets updated and it gets put into adoption across the country. And there's amendments, so every state's not the same, okay? But in the IECC in 2021, they have now reached a point where it doesn't matter where the ductwork is, you have to do a duct test, because they realize you're not going to be able to balance the system, get the air from where it needs to come from out to where it needs to go into every room, and balance that and have a comfortable home, particularly in a really tight home, in order to meet today's construction standards, right? So if you're doing a duct test under today's IECC code, and you're doing it during rough-in, you're allowed to leak 3 CFM per 100 square feet before that air handler is installed, okay? There is a rough-in test that should be done. You don't have to do a duct test, but you need to test that stuff before it's all put behind drywall and all that stuff and finish, right? Now, of course, when the home's completed, you do have to do a HERS rating. So a HERS rater typically does this test anyway, whether you test it or not. So it's part of the HERS test, right? So when you're doing the test, remember that the code requires you meet the 4 CFM per 100 square feet that the unit services if the ductwork is not entirely with the air handler, entirely within the building envelope, or the thermal envelope, right? If the duct system is entirely within the thermal envelope and the air handler is within the thermal envelope, then you can actually leak as much as 8 CFM per 100 square feet, which is actually a significant number, right? If you can imagine, for code purposes, that's a lot of leakage. But just because it's going within the space and it's coming from within the space, it doesn't impact the load as much, because really you have 0 losses and gains, right, in the load calculation software in that example. So it just impacts balancing and comfort, okay? So a couple of key things there when it comes to duct testing. Make sure you don't just replace the box and put in a new system thinking it's going to be more efficient. You could actually increase your electric bill if, let's say, you go from an air conditioner to a heat pump and you have a leaky duct system, and the thing is variable speed and it's always ramping up and always trying to overcome that leaky, poorly insulated duct system up in an attic or a basement, okay? Also, if you have a leaky duct system in a basement, your latent gains will go up. So here in the Northeast, most duct systems are actually in the basement or in the attic, right? So in the basement, when you're pulling in all that moisture down there, your latent gains will rise significantly. And I can usually tell the ductwork location just by looking at the losses and gains when it's average or less when it comes to leakage, because you can see the latent jump way up on a leaky duct system in a basement, right? So really important, seal that duct system, do the testing. If you have never identified the testing, like in order to identify how bad that duct system is, of course, a total leakage test tells you a number, but then you have to find where the leaks are, right? So when you're doing a total leakage test with a duct blaster, if you connect it to the return, it's going to overweight the leakage in the return, right? Because that's where the pressure is going into the duct system. If you connect it to the blower section of your existing air handler, that probably leaks like a sieve, because it doesn't have the new standard of 2% of airflow or less, right? That's what new ducted systems in the IECC should have. New air handlers, there's a stamp for that. If you are testing it at the air handler and you have a leaky air handler, it overweights in the total leakage test the leakage in the air handler, right, where you're introducing that pressure. So a lot of people, when you're doing like home diagnostics, prefer to do pressure pan tests. They'll actually depressurize the entire home to 50 pascals. And when the ductwork's outside the building envelope, they can take a pressure pan, cover your register, and actually see the pressure difference and how much pressure is actually going into that duct when you block it, right? So you can actually measure leakage of each run, and it helps identify which runs are the most leaky. Maybe there's disconnected ducts and that's under insulation, or it's hard to find up in an attic that's hard to crawl through, right? So that way you know where to spend your time when you're doing that leakage test. Also, when you're actually physically sealing it and you pressurize the duct system when you're doing a total leakage test, the best method is just to feel where the air is coming from. Crank that thing, feel where the air is coming from. And as you start to seal further and further down the line, the pressure continues to build up further down that trunk, right? So you'll be able to feel the leakage. So always start close to the air handler or close to the return where you're pressurizing it from, and work your way back when you're sealing, okay?
Hi, I'm Chris with HVAC Pro Blog, and I want to thank you for watching my videos every week. If you'd like to help support our channel more, head over to my Patreon page where I have options for as little as $8 a month. If you'd like to join the HVAC Design Society and get your questions answered, like I just showed you, we do this monthly for our elite members. So a special shout out to all those HVAC Design Society members in order to help feed us with content and supporting the channel while getting your questions answered. Thanks for joining me this week at HVAC Pro Blog, where we provide advice for residential system design, quality installation, and system diagnosis. I'll see you soon.